Okay, so we're taking a look at our two-way table worksheet. Let's look at our first example together, student athletes. The data from a survey of 440 students are shown in the table. The students were asked whether or not they were on the honor roll and whether or not they played a sport. So here's our table of information right here. There were 440 students that were polled, and they were asked if they are only on the honor roll, if they only play a sport, or if they're both. So you couldn't be more than one of these. You're either just on the honor roll and that's it, you just play a sport and that's it, or you do both. You play a sport and you're on the honor roll. So complete the Venn diagram. So what we have here is this area right here is the only honor roll students. So look at your table and decide how many students would go in this only honor roll section. For the sports section, this would be kids that only played a sport over on this side. Now where the Venn diagrams cross are the students that are both. The students that both play a sport and are on the honor roll. So we have 250 inside. There are 115 kids that do not play a sport, but they are on the honor roll, and 45 kids that do play a sport but are not on the honor roll. Okay, number 2. Is the ratio of the value of a subtotal, relative frequency is the ratio of the value of a subtotal to the value of the total. What is the relative frequency of a student that is on the honor roll and plays a sport to all students that are on the honor roll? So we want to create a ratio of student that is on the honor roll and plays a sport to all students on the honor roll. So we're going to make a ratio out of these two numbers. Okay, students that are on the honor roll and play a sport are 250. So there are 250 kids that are both. Ratios are written with a colon, compared to students just on the honor roll, or to all students on the honor roll. Okay, so 250 are both. How many students are on the honor roll? Let's think about this for a second. I have 115 that are honor roll only, and 250 that are both. So for these students right here, I'll underline it in red. All students on the honor roll include the honor roll only and honor roll sport kids. So we're looking at 115 plus 250. So we have a total of 365 kids that are included in the honor roll. Number 3, is there evidence that students that play sports are also on the honor roll? That's what you have to decide. So does this prove to you that students that play sports will definitely be honor roll? That's what you have to think about. You answer that on your own. Next page. Two-way table shows data from one sample group as it relates to different categories. The same information from a Venn diagram on the previous page is shown below as a two-way table, where one category is represented by rows and the other category is represented by columns. The two categories are shown are play a sport and on the honor roll. So let's take a look at the chart that you have there. So what we were given was the number of students on the honor roll, the number of students that play a sport. Okay, so on the honor roll only was 115. Take a look at your Venn diagram. Play a sport only was 45. And then the kids that were both, remember that's the one that we added together with my 115, was 250. So 250 play both. Okay, so 250 are both honor roll and play a sport. For this 45 right here is only play a sport, not on the honor roll. 115 is on the honor roll but does not play a sport. Okay, one thing I want you to look at is look at this number right here. This number was not talked about on the last example. What about kids that don't play a sport and are not on the honor roll? Okay, think about that again for a second. Kids that don't play a sport and are not on the honor roll. That would be 30 kids. If And you can go back and take a look and see. But this would be a piece of information that would be left out of a frequency table that you would have to come up with on your own. Okay, so I just wanted to explain how that table is set up. Let's take a look at the next part. Oops. Here's an example. Felipe surveyed students at his school. He found that 78 students owned a cell phone. 57 of those students also own an MP3 player. So 78 have a cell phone. 57 of those 78 kids also own an MP3 player. There are 13 that do not own a cell phone but own an MP3 player. So there are 13 that do not own a cell phone but do own an MP3 player. 9 students don't own either. Construct a two-way table. So let's take a look. So this right here, 57 are the kids that are both an MP3 player and a cell phone. 57 kids. It's right here. Okay. Can we take a break? Yeah. Okay, let's look at the next part. Let's look at these 13 kids. 13 students don't own a cell phone, but own an MP3 player. So no cell phone. Okay, here's our no cell phone. Yes, MP3 player. 13. And then if we look at our last one, the 9 students don't own either device. That's where our 9 comes from. Okay. Our total, 78 kids, and that tells us right here. 78 students own a cell phone. Okay, so 78 students own a cell phone. Cell phone, 78 total own a cell phone. So we need to fill in these missing blanks. So if we're looking right here, I have a little side note. Okay, this is going to help us with this top row. Okay, so step 1 is create the table. Step 2 is use our reasoning to complete it. So if I have 57 kids that have an MP3 player and a cell phone, 78 kids total have a cell phone, what number would go here? 57 plus what equals 78? 57 plus 21 equals 78. So at this point, we're just kind of looking at what's empty and what we know that we can fill in. Okay, so if I have 2 of my numbers, I can come up with the third. So if I look at my MP3 player row, 57 and 13 makes 70. If I look at my no MP3 player row, 21 also own a cell phone but no MP3 player. 9 don't have either. So that's 30 kids in the no MP3 player area. 70 plus 30 is 100. And so if I look at my total row, 78 plus what will equal 100? 22. So basically you just find a spot that you can determine an answer, and then it'll kind of domino effect from there. Okay, now you try this next one on your own. So hit pause and do that one. Okay, so if you're struggling with the canoeing or the summer camp activity, let's take a look and see what information we have. To start, there are 150 children at summer camp. So this would be our grand total. And that is going to enter in right here. So you have 150. When you see total and total, that's your grand final total. Okay? So next thing we look at, 71 signed up for swimming. So what we're looking at here is if I look at the swimming row, I have some kids canoed as well. Some kids did not canoe. And this is the total kids that swam, not even worrying about canoeing or not canoeing. So ignoring canoeing completely, this is just straight swimming. In straight swimming, we have 71 kids. Okay, knowing that, if we look at next up, it says there were a total of 62 children that signed up for canoeing. So the same thought process for swimming goes for canoeing. So here's our canoeing section. Not worrying about swimming or not swimming, we have 62 kids that signed up just to canoe. Some of them swam as well, some of them did not. Okay, so having started this little section, come up with where the 28 is going to go, and then complete the rest of your table. Okay, let's look at the next page. Patterns in two-way tables. We have our essential question, read along with me. How can you construct and interpret two-way tables? The frequency is the number of times an event occurs. A two-way table shows the frequencies of data that is categorized two ways. Rows indicate one categorization, columns indicate the other. So let's take a look at example 1. A poll of 120 town residents found that 40% own a bike. Of those who own a bike, 75% shop at the farmer's market. Of those who do not own a bike, 25% shop at the farmer's market. So here's what we have. We have two pieces of information. Information 1 is bike or no bike. So some people have bikes, some people don't, which is true. The second piece of information is farmer's market. Some people go to the farmer's market, some people don't. What we do with a two-way table is we want to see if there's a correlation between people that have bikes and people that go to the farmer's market. So we have 120 people in town. Some have bikes, some don't. Of those same 120 people, some go to the farmer's market, some don't. So we would use a table to decide, is there some sort of relationship between owning a bike and going to the farmer's market? There might be, there might not be. But that's what we do with the two-way table. So we're not going to fill this out yet. All the steps below will walk us through this section, so we'll do it together. Okay, so now we're going to start filling in our table, but we're going to go along with our steps here. So A says, start in the bottom right cell of the table, enter the total number of people polled. So we want the total number of people, and that's 120. So that goes in our total. 120 people. B says, fill in the right column. 40% of those polled own a bike. So here's where it gets tricky. Now we're looking at percents. Okay, so 40% of the people polled own a bike. So what we're looking at here is 40% of 120 people. Our total is 120, 40% of those people own a bike. Now when you're multiplying percents and numbers, we want to turn our percent into a decimal. 40% becomes 0.40. Of is multiplication, 120. So when you multiply 0.40 times 120, you get 48. That means 48 people that were of the poll, 48 people owned a bike. It's going to go in this row, in this little section right here, because this is people that own a bike. We don't care about farmer's market or not. They're saying 40% of the total have a bike that they own. 48 total people own a bike. Okay. If we look at our next little step here, the remaining people polled do not own a bike. The number that don't own a bike is 120 minus the 4. So 120 people, take away the 48 that own a bike, and you are left with 72 people own a bike. Or 72 people do not own a bike. Okay, so basically they're just walking you through the step of filling out this total column. Okay, next one. Now for C and D, let me refill out our table up here. So far we have 48 people own a bike, 72 do not. 120 people were surveyed. So let's look at C. C says, fill in the top row, 75% of those who own a bike also shop at the market. So 75% of those who own a bike also shop at the market. So how many people own a bike? 48. So this is saying 75% of the 48 people. Okay, so again, 75% of the people who own a bike also shop at the farmer's market. So this is where we start seeing some connections. 75% of the people that own a bike, that's 48. 48 people own a bike, 75% of those people is what? So 75% is 0.75 times 48. So 0.75 times 48 is 36 people. So of my total bike owners, 36 go to the farmer's market. The remaining bike owners do not shop at the market. The number of bike owners who do not shop at the market is blank. Now we're looking at this spot right here. 36 plus what is 48? It's got to be 12. If 48 people own bikes, 36 go to the farmer's market, that means 12 do not. Okay. D. Fill in the second row. 25% of those who do not own a bike shop at the market. So 25% of the people that don't own a bike. So the people that don't own a bike are 72 people. So 25% of 72. So 72 people do not own a bike. 25% of them go to the market. So 0.25 times 72. That's 18 people. So 25% of the people that don't own a bike do shop at the market. So no bike market people are 18. The remaining people without bikes do not shop at the market. So basically we're looking at what are we going to place right in here. 18 plus what is 72? We're just doing simple subtraction. 72 minus 18. And you end up with 54. Okay, so pause if you need to. Next page. Okay, now we're down to E and F. Let me fill my table back in. Okay, so E, fill in the last row. In each column, add the numbers of the first two rows to find the total number. So at this point, we just start filling in what we have. We can kind of domino effect. So if I look at my farmer's market column, 36 and 48 is 54. 12 and 54, 66. Double check everything. We can make sure our table is correct if we just double check all of our math. 54 and 66 is 120. Now F says, what percent of all residents polled shop at the farmer's market? Okay, so now we're looking at a little bit of different information here. So what percent of all residents polled shop at the farmer's market? So who shops at the farmer's market? That's 54 people out of 120. So 54 out of 120. That's 0.45. 0.45 becomes 45%. 45% of the people polled shop at the farmer's market. So they could use this to determine a lot of things. They could say, well, we have a lot of people that bike that also go to the farmer's market, so they could make sure that they gear some advertising towards people that ride bikes, or maybe they have some different booths that they start welcoming in that for bike people that go biking. So it just would help a business or help somebody make decisions based on people that bike in the farmer's market. Okay, so now the next one, I want you to go ahead and try number 2 on your own, as well as number 3. And as for the practice, we'll have the key for that up tomorrow.